Hello, friends. We're continuing with our study of precalculus. We're in Unit 3. We just learned about periodic motion. We're going to switch gears a little bit, but we're going to get back to periodic motion, and we're going to look at sine, cosine, and tangent. Now, you're thinking to yourself, I'm in precalculus. I've already learned about sine, cosine, and tangent in geometry, in algebra 2. But here's the thing. We're going to standardize this a little bit. We're going to put it on an XY coordinate axis. We're going to standardize this because there are some conventions that we use in precalculus and calculus and physics. Um, and so, first thing that we're going to kind of like agree on for our notation, for our expression, is what we call the standard position. So, we're going to measure all of our angles from the x-axis, the positive x-axis, and we're going to measure them counterclockwise. This is the positive direction for measuring angles, counterclockwise. And then we're going to go, the angle is going to start at the standard position and end at a terminal ray, some terminal ray where it starts at the origin and then goes out. So the angle formed here is with the standard position and then some terminal ray. And just another common notation is that we use theta, capital Greek letter theta, for the angle measurement, right? It's like a circle with a line in it or a circle with a squiggle in it, you know. So, sine, cosine, and tangent. Don't forget, and in case you haven't learned this, SOHCAHTOA. I still say this in my head. SOHCAHTOA. So sine is the ratio of the opposite over the hypotenuse. Cosine is the ratio of the adjacent over the hypotenuse. Tangent is the ratio of the opposite over the adjacent angle. SOHCAHTOA. I learned in high school that it was like the name of an Indian, and we, made up a story about him, whatever. But the name stuck, and it helps me to this day be able to take care of these angles. Because the idea is this: take a look. If we have some terminal ray or some angle, so we make a circle, and now it has a circle radius. So look, r comma 0. So what's the radius of the circle? R. Right? That's the length from the origin, the center of the circle, to the edge. So that's true here also. When I have this, what happens is my x and y coordinates, I basically create a right triangle. A right triangle where y is the opposite side from the angle, right? Here's the angle. This is the adjacent side. And so the adjacent length is just the x coordinate. The vertical length, right? The vertical leg, the length of that is the opposite side, and that's just the vertical coordinate. That's the y coordinate. And then I have r. If I want to have angles bigger than 90 degrees, going all the way around, then I can have negative x values. That takes me into the second and third quadrants, and negative y values. That takes me into the third and fourth quadrants. So we can get all angles from 0 all the way to 360 degrees, and we can specify them using x and y coordinates. And so sine of theta is, opposite over hypotenuse. But here, using this, sine is y over r. Cosine is x over r. It's the horizontal, right? The adjacent piece over r, it's the hypotenuse. Tangent, opposite over adjacent, or in this case, y over x, the vertical over the horizontal components of our triangle that's created. So let's look at an example. Looking at this right away, what I want to do is label some things just to help me visualize everything. So this is a 3, okay? And then this is the opposite side. This is the y, and then the adjacent side is the x. Again, it's a right triangle here. So it says, what's going to be true about cosine of theta, right? So it starts off standard position, coordinates of here, x and y, all that kind of stuff. Well, cosine of theta, right? Cosine is adjacent over hypotenuse. So cosine of theta is going to be adjacent, which is x, over the hypotenuse, which is 3. So you're going to see this over and over again, that r is the hypotenuse, x is the horizontal, is the adjacent, and y is the opposite. So the answer here has got to be A. All the others have different things, right? Y over 3, y over x, 3 over x. But we know the answer for cosine of theta has to be x over 3. In this one, they give us coordinates, right? We have actual numbers for this one. So this coordinate is 3, 4. So going down to here, the coordinates of P are going to be 3 comma negative 4. Notice this angle goes all the way around. Right? Okay, so the adjacent side, the horizontal is 3, the vertical is 4, and this is 5. It's a 3, 4, 5 right triangle. Remember the common Pythagorean triples, right? 3, 4, 5 is one of them. And so I'm going to, negative 4. So sine of theta is opposite over hypotenuse. So this is just negative 4 over 5. Cosine of theta is 3 over 5, right? That's the adjacent side. That's the horizontal over the radius. And then tangent is uh, opposite over adjacent. And so that's negative 4, the vertical, over uh, the adjacent, which is the horizontal, 3. Okay. Now this is the basis for the next few examples. We've got a circle with radius r, and we've got some various points, P, Q, R, and S. Q, R, and S are found by reflecting point P over the axes, the different directions, of course. Right? And so I'm just going to label, just to help myself out, this is R, this is R, this is R, and this is R. Here, point Q, and actually I'm doing example 3 right now. Point Q has coordinates negative x, comma, y. Right? So it's the same height, y, and it's the same distance from the origin, but just on the other side. So it's negative x. Point R has coordinates negative x, comma, negative y. And then S is x, positive x, but negative y. Okay, so for example 3, I've already done this. You just see the diagram. Example 4, find sine of the angle whose terminal ray intersects at point S. Okay, point S is over here. And I want to find sine. So sine is going to be this, negative x, or negative y over r. So sine of angle theta, whatever that angle is negative y over r. Cosine of q, cosine at q. So cosine is, again, the adjacent over the hypotenuse. So that's negative x over r. Example 6, find the tangent at point R. Point R is down here. Tangent is opposite over adjacent. So that's going to be negative y over negative x. Okay, so tangent, theta, negative y over negative x. So that simplifies to just y over x. Okay. Example 7, it says, let theta be an angle in standard position whose terminal ray coincides with the line y equals negative 3x. Let's draw this. Okay, so here's our angle, y equals negative 3x. I'm in the second quadrant. And so as opposed to y equals 3x in the fourth quadrant, right? The terminal ray is in the second quadrant, they're telling us. Okay, what that means, again, so I can create a triangle here where the coordinates, so this is going to have radius r. The coordinates here are x, really negative x, right? So negative x, comma, uh, negative 3x. So the way that I would calculate the y would be I take whatever the horizontal coordinate is and I plug it into the y. I also want to have an expression for r. So what I'm going to do now is I'm going to be finding sine, cosine, tangent and plugging in these values and simplifying to see what's the ratio. I want to know what's the ratio between these sides. That's what trigonometry is all about. It's about these ratios. And so what I can do is, how do I find the length of side r? Well, it's a right triangle, and that's the hypotenuse. So how do I find the hypotenuse? Well, you should know that Pythagorean theorem, right? R squared equals x squared plus y squared. So r squared equals x squared plus y is negative 3x squared. So r squared equals x squared plus 9x squared. R squared equals 10x squared. That means that r is x times the square root of 10, and x equals r over the square root of 10. But I am in the second quadrant. I have negative values for x. So I'm just going to say that transforming this to x equals negative r over root 10 as I'm plugging in my values for finding these, for solving these parts of example 7. So sine of theta, so that's the vertical over the hypotenuse. So that would be y over r. So y is negative 3x over r, but now I have an expression for r, right? So it's negative 3x, or negative 3 times negative r over root 10 over r. The r's cancel out, and the negatives cancel out as well. So this ends up as 3 over root 10. Right? So this is what this means. The ratio of the opposite to the hypotenuse in this little triangle we've created is always 3 over root 10. Doesn't matter if you make the radius bigger, then that makes the sides bigger as well, wherever you put a point on that line. Right? But the ratio is always 3 over root 10. Cosine is going to be x over r. Now again, x is negative r over root 10. So right away, the r's cancel out. I'm just left with negative 1 over root 10. And then tangent is y over x. Well, y is just negative 3x. And we can see right away the x's cancel out. And we end up with negative 3. It is the slope. Tangent of theta is the slope of the line, right? Rise over run, opposite over adjacent, same thing. So it all ties together, right? Everything fits together. It's beautiful. It's part of the beauty of math. So thanks for watching. Don't forget to like and subscribe.